both type of devices. So, but how can we integrate BLE capability into our wearable? So they are commercial BLE chips, and the most popular ones include the Nordic Semiconductor nRF 52 series. This is the chip that we will be using in our class. There's also Texas Instrument, BLE chips. There are also a few other, manufacturers, but in our class, we will be using the Nordic Semiconductor one. So there are many different chips in this family, and this one named nRF 52832. So this is a general purpose BLE chip. So that support, most of our wearable applications. There's a more advanced version, nRF 52840. So this is a higher-end BLE chip. Yeah, it supports, more advanced functionality and it has more, memory. So we will be using the H32 in our class. So just a more detailed view of the, H32 BLE SoC. First, it has two different packages. This called QFN48 packaging is 6 by 6 millimeters. You can see on this, in this packaging, all the pins are on the 4 sides. So this makes the chip relatively big, not so big, but relatively big compared to the smaller packaging, which is called WLCSP, which is about 3 by 3 millimeters. So in this, WLCSP packaging, so all the pins are under the chip. So there's a ball array. You see there's a ball array. So these are all the pins. So this makes your chip much smaller, and you will be soldering this chip in our class. So in lab 5, you will be soldering this chip. And we have a block diagram of the BLE SoC here. So there are a lot of things going on in this SoC. So we have a CPU. There's a CPU here, which is 64 megahertz on Cortex-M4 CPU, which supports floating point calculation. Then this memory, 512 kilobytes flash and 64 kilobytes RAM. Okay, so why do we need two types of memory here, flash and RAM? What's the difference? Go ahead.
Flash also contains the bootloader and the firmware, while RAM contains volatile variables and stuff such as like that.
More to add?
That's said it better than I was going to say it.
Okay. Yeah, so flash is where, so we need to program our BLE SoC. So flash is where your program lives. And when your chip loses power, so, data in flash doesn't disappear. So your program will still live in the chip. And RAM is random access memory. It's mostly used for, temporary data generated when your program is running. And once your chip loses power, all data in RAM will disappear. So it also, the chip supports different wireless protocols. So it supports BLE, it also supports NFC. Then, it has two different clock sources, 32 megahertz and 32 kilohertz crystal oscillators. Our computer chips run on clocks. We always need clocks. And they have digital interfaces. So including SPI, which we will talk about, TWI, or more generally, I2C, then UART. So, so basically, we have sensors that, generate digital data. So like our accelerometer. So they generate digital data, and we have to, read the data digitally. So there are different protocols, including SPI, I2C. So there's also analog interfaces. Sometimes our sensor just generate an analog signal, like a voltage. So we have to convert that analog voltage into a digital signal because our processor does everything digitally. So that is done by analog digital converters, ADCs. So this chip has, 8-channel, 12-bit, 2000 kilo samples per second, successive approximation ADCs. This is one type of ADC. We'll talk about that later in the term. So there are also other peripherals like timer counters, real-time counters, temperature sensors, watchdog, random number generator. So we don't need to care about these things. And probably the most important thing you want to care about here is general purpose IOs, GPIOs. So can someone explain what GPIO is? Oh, go ahead.
It can be either an input or an output pin, depending on what you set it to.
Yeah. So these are for general purposes. So, so there are 32, GPIOs here. So they are for general purpose. That means you can configure them as input or output, and you can use them in SPI mode, I2C mode, or you can use them, in ADC mode. So, these GPIOs can be reprogrammed to connect to different modules like SPI, I2C. So these are the pins we will use to connect to our sensors. So, there are a lot of things going on in this BLE SoC, but, we don't need to panic because we are not using everything, and we configure a lot of things for you.